Hello, welcome back. Um, so now let's think about a little more generalization with four reservations case. Uh, Still, y is the number of cancellations, but now there are four reservations: A, B, C, and D. And everything else is the same: 10% probability of cancellation, and cancellation is independent. And I should have asked this question in the previous video. Now we are interested in the probability that two reservations are canceled. Two reservations of four are canceled. So try this for a while. Remember, there are two steps. First, you have to count how many different combinations, different pairs from A, B, C, D you can think of. That's the first part. And the second part, if you knew who canceled, then what is the probability? So if you can think about multiple pairs of two cancellation out of four, and then for each of them, calculate the probability. So that's how you calculate this probability. Briefly try this, and it's just if you can do this, that's really great. But even if you can't do it, that's not a problem. This is just in the process of getting to the answer, general uh, rule. So just take a moment and try this. I will turn to the next page in three, one, two, three. So first, let's think about the probability of a single outcome that satisfies two cancellations. And the idea was, because there are two cancellations, there are four reservations, and two are canceled and two are not. So probability of cancellation multiplied twice. Cancellation happens twice with probability 0.1, and probability of non-cancellation is 0.9, which happens twice. So multiply four number. You have to multiply four probabilities because there are four reservations, and depending on it, if one is cancellation, then you have to multiply 0.1. If not, 0.9. So four numbers are multiplied, and the 0.1 and 0.9 are multiplied as many times as that happened. So it's now what remain. This part is more intuitive, but what remains is to calculate the number of combinations. So there are four, and I said there two are canceled. Then how many combinations can you choose from? Like, can you make up like these two, these two, these two, and these two, and like A B A C A D and like B C B D? How many? And once you can count that, you can count multiply this number to the single probability. This is probability of single outcome. Now you have to calculate how many outcomes included in that event. The brute force method, list all the possible cases, and this is the answer. There are 16 number of so there are 16 number of combinations when you have four reservations. So four reservations, and each reservation may be canceled or not, canceled or not, canceled or not, canceled or not. So two possibilities for each reservation. So then, when there are four reservations, the total possible combinations are 16. Among these, we are interested in two cancellations. This guy, cancel, cancel, no, no, cancel, no, cancel, no, cancel, no, no, cancel, and six, these six outcomes satisfy y equals to 2. So among 16, only 6 outcomes satisfy the event. Then if you know that there are 6 possible outcomes, the answer is 6 times the probability of a single outcome. There are 6 outcomes, and each of them has this much probability. So the final answer is 4.86. then you may think, okay, now it gets weird because there are six possible outcomes, which is clear if you write down all possibilities. But where is this number from? Because there are four reservations. There are only four reservations, and we are interested in two cancellations, and probability is 10%. Six, where is six from? There is no three. Like six is two times three, but we did not have three at all in our analysis. So that makes this problem more complicated and counterintuitive. I am going to generalize this pattern uh, and a formula. Um, I so frankly speaking, I it's really difficult to tell you the intuition behind it. So it may take another hour just to explain why we get to this rule. The formula is called the combination rule. So I'm not going to tell you the intuition. Throughout this course, as you may feel this, I try to explain the underlying intuition as much as I can, but this is the only exception. I gave up. I gave up telling you how we get to this rule. Just remember or get used to it. Just accept this. Take this as granted. Or maybe I don't know like which class teaches this one. Maybe in a math course can cover this. I'm sure that it will take on one whole lecture to explain this. So I will just give you the definition and the formula instead of explaining this. First, we have to define factorial. Mathematical symbol factorial is an exclamation mark. So n exclamation mark is said. It says n factorial in mathematics. N factorial is the product of all natural numbers up to n. So consecutively multiply all the numbers between 1 and n times n minus 1 times n minus 2 and down to 1. And then we are going to use this notation. This notation is used in the final formula. And then what we want actually is the number of possible combinations when you choose y out of n. It is denoted as n chooses y. So it looks like a vector notation, but actually it's a combination. So it often reads as n choose y. And according to Wikipedia, there are many different notation used in different countries. So if you may have learned it, but using different notation, but in all the textbooks we use, and maybe in the United States or by the maybe American Association of Mathematics officially uses this notation as for the combination rule. So I will stick to this notation. Notation itself is not a big deal in statistics. It's just one part of the rule. So anyhow, I will use this. And chooses y. So in our example, it says there are four reservations, and among four, you have to choose two canceled reservations. So 4 chooses 2 is what you need. 4, n equals to 4, y equals to 2. Then conclusion is that the combination rule is how many different combinations possible when you choose 2 out of 4. It follows this. N factorial divided by y factorial times n minus y factorial. Or to expand this product, n times n minus y, 1 times n minus 2 times up to n minus y times plus n minus y plus 1. And denominator has another sequence of multiplications, y times y minus 1 times y minus 2 times 1. Really weird rule, weird pattern. It's very hard to explain why we have this. So that's why I give up. Just I'm not confident I can explain this in like 10 to 15 minutes. So I will just show you this as a rule. And special cases you need to know is when zero, and when you choose zero out of n, there is only one case. You choose nothing. That's it. That's the only so. Or in our example, there are n reservations and no reservation is cancelled. How many different combinations? Only one case. Everything should not be uh, cancelled. So it's only one case. Or n chooses n when there are n reservations, and what is the how many possible cases for uh, there are n cancellations. When there are n reservations and there are n cancellations, how many possible cases? Only one case. Everything is cancelled. So in this special case, denominator becomes 0 factorial. So we are simply using 1, and it's intuitive. The number of combinations is 1 when everything should be cancelled or should not be cancelled. Anyhow, like let's think about with more numbers. So this general rule looks very uh, complicated, daunting, but when you see actual examples, it's not that uh, not much of a complication. So, but still complicated enough. But there is pattern, clear pattern. So first example, suppose that you choose 5 random cards. You get 5 random cards from a 52 standard playing cards deck. How many different combinations possible? That means you are choosing 5 different cards from 52. So then, according to the formula, you have to multiply 51 times 50, 52 times 51 times 50, 49, 48, 47, da 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 up to 1. So, of course, you cannot do that by hand. But in the after all, most of them are cancelled out. Many numbers are cancelled out by the denominator. So in the end, what you are going to do here is first multiply 5, 4, 3, 2, 1 in the denominator, and there are 5 numbers in the denominator. Then also there are 5 numbers in the numerator, starting from 52. So numerator starts from 52 and denominator starts from 5, and multiply the denominator and the numerator have the same number of numbers multiplied. So 52 and multiply 5 consecutive numbers. Similarly, like think about another example. You can choose 2 pizza toppings from 10 possible choices. How many different pizzas, different combinations can you make? And it's 10 chooses 2. You choose 2 different toppings from 10 choices. Then also the rule is the denominator starts from 2, numerator starts from 10, and denominator multiplies all the numbers down to 1. And there are only 2 numbers, and numerator has only 2 numbers multiplied in the numerator too. So same number of numbers multiplied in both numerator and denominator. And of course, they start from these 2 numbers and decreasing starting from these 2 numbers. Then, like after you read these patterns, try this. Suppose that there are 5 reservations now, and 3 of them are cancelled. Then how many combinations possible? Try this, and after you finish the algebra, watch the next video. Thank you, and hope you enjoy. Find the pattern soon.